Hello there. So now we're going to be using our circuit diagram of our um, Twinkle circuit to draw it and see if we can simulate it in this FastLad circuit simulating software. We will then, in the next tutorial, we're going to see if we can use our scopes and more advanced scanning technique so we can actually understand how the circuit itself is working. But for now, we're just going to light up our circuit of our Twinkle, and we're going to see if we can get it to simulate how it was actually working in the real world. So we're going to start by going to our blank circuit. Right now, so it's got a bit of the scopes over here, but the prompt over here showing the actual time and when we start hovering over individual components, that will show. So to start our circuit, we're going to go to inputs and we're going to put a voltage source terminal. We'll do this over here. We're going to right click and we're going to edit, and let's just make this, if our circuit is 12 volts is our maximum, let's just put down our maximum voltage for now. We'll deal with more of that later. We're going to add a resistor. Our first resistor in our circuit is a 470. So if we go down here and we right click and we'll edit, we'll make this our 470. Okay, we can then hover over this so it's blue, press Control C for copy, and then Control V, and it's going to paste the identical resistor where your mouse was. Now this is because I'm using a Windows PC. If you see the edit over here, the shortcuts for the Control Copy and Control Paste, Control C, Control V. If you're using a Mac, I'm sure you have different commands. I don't exactly remember what those are. Or if you're using another sort of software system that has different shortcuts, you can use that. So we have our resistor over here. Now we want to move this. The issue is when we want to move this resistor, we can't just click and drag because it's going to make new resistors. Let me undo those. So what we have to do is if we hold down the space bar and then you click it, hold down the space bar, then you can click and you can move the resistor around. So I can move this resistor over here, make it the same height as that one. Cool. And let's make another resistor and let's also make that the same height over there. Great. So now I have those resistors. Now I'm going to make my 10k resistors. Control paste. Let's edit this resistor over here. Edit. Let's make it 10. We can write 10k and the system will automatically understand that goes to 10k. We can also write 10,000 and it will still work. And then we're going to go here. We can also right click and copy, and then we can go. We can then choose to right click and no, we can't right click and paste. We just press Control V, and let's just drag this resistor down so it looks nice and pretty. So there is our 10k. So let's count. We have 1, 2, 3, 470s, and 1, 2, 3, 10k. So we are good to do that. Next we have our capacitors, which is under passive components. We know we have a electrolytic capacitor, which is a polarized capacitor. So we're going to press capacitor polarized, and let's work our capacitors. So we can click and drag our capacitor across. Now the symbol for this capacitor is slightly different than the one we have in our circuit diagram. The straight line represents the positive by this this version of the symbol for it, and the curved area represents the negative. So we know that the direction of our capacitor is correct. And if you ever get it wrong, you can always right click and you can say swap terminals, and it will swap the location around. So if you have it incorrect, let's go back to swap terminals. And again, we're going to copy, we're going to edit it. We want this to be 47. Apply. And then we're going to go over here, we're going to copy, and we'll paste another one in here. Oops. And then our last capacitor is going to be somewhere over here. Right, so let's talk about connecting. Well, we have to connect these capacitors up. We can go and we're going to connect them by some wire. So wire can go down over here. That wire can go down over there. This can go there, and this can go like that. We are then, that capacitor goes to there. We know that this is going to go all the way back to our 10k based on our diagram, but we'll save that one because we need to work with our transistors first. So let's talk about our transistors, which are our V1s, our V2, and V3. So when we go to draw transistor is an active component. We have two versions of transistors. We have an NPN and a PNP. So there's two ways we can make sure we have the right transistor. Let's make sure. Right now I'm clicking the NPN. Right, there's our NPN transistor. And let's draw the other one. Let's draw the PNP. So if you actually look at the transistor itself, this over here, we see the arrow is going out of the transistor, which actually relates to the same on our circuit diagram. The arrow is going out. On a PNP, the arrow is going into it. So we can use our circuit diagram. Now, let's say we don't have the circuit diagram and it just gives us the number of the transistor. The other option we can do, let me just load up over here. So over here, if you Google the name of your component, and you're going to be doing this a lot in electronics, so the 9013 is a component that you could be a component that you'll be searching up will be the 9013, and you'll see there on the data sheet. So I literally type in Google 9013 datasheet PDF, and once you follow the links, you'll get to a datasheet like this. It has a lot of important information, as you can imagine, for a company that needs to use this in an official part. Ooh. If you have to use it in some sort of official context, you have like the voltages. You also have like the exact dimensions over here. So that's relevant. We just there we go. So you have the actual parts and dimensions. But what we care about over here is the front of the data sheet. It has over there NPN. So we know this is the 9013 is an NPN, so we can add that in. If we click the other data sheet for the 8050, we can see that that one as well is it says over here. Oop, shouldn't be able to move that. But NPN. So it's also an NPN. So these are both NPN transistors. Let me load up the main screen again. So we know that is correct. General functionality. We can use our scroll wheel to zoom in. We can also use our edit button to zoom in. And actually rotating the stuff around, if we hold the Alt key, we can click and drag our circuit. So you can get more detail by zooming into a specific area. You can also press the space bar. And what that does is now my mouse is no longer in the crosshairs and it's in a mouse form. So I can click and... Sorry, when I'm in mouse form, I can click and drag, and I can click multiple components, and I can delete them. You can also copy and paste them, which we're going to do later with our LEDs. So let's go and let's add in the NPN. It needs to be somewhere around here. Let's make it short. There we go. That's our NPN. And what we're going to do is, since they're all the same, the LED lights and the NPN transistors, let's make a single group and then we'll copy paste it along. So we have our NPN transistor over there. Let's get a light. So that's an output. It's going to be our LED. We know our LED is going to be an arrow pointing down. So if we click and drag, we have our arrow pointing down. We can then make another LED. We can just do 5. So we have consistency. So we have 5 LED lights. We have to link these together. Now let's learn about, let's do a bit of a revision when it comes to connecting our lights together, in case you're coming here straight and you haven't seen the previous video. When it comes to connecting our wires, if we want to connect our wires, we have to collect each black circle to the next one. So as we connect all these black circles, there we go, all those LED lights are collected together. They have the black dots, just like our circuit diagram. The black circles or black dots represent that those wires are actually connected. If we do a scenario over here where I'm just going to do a single line across all the circuits in one go, we see how these are red dots. These over here are red dots, so they're actually not connected. It's the way the circuit is telling us something is up. So later we can attach those to other things. So with our circuit, let's go and make sure these are all red dotted and connected together. Sorry, all black dotted and connected together. That is great. We want to connect the wire up to our transistor. Okay, that is also great. Let's make a wire going up and a wire going out, so later we can know we can connect to the other parts of the circuit. So these look like our a single row of LEDs. We're going to press the space button to get into normal mouse view. Then we're going to click and drag, and we're going to Control C to copy, and then paste it. And we're going to move it around into a nice location. That looks fine. And do the same thing over here. Again, that looks... Yeah, that'll be fine. So let's go and we'll get a wire, draw, add wire. So now let's just finish off this circuit. We have all these lines at the top. They need to be connected together. And we need these wires at the bottom to be connected together. So all our transistors and our LED lights are connected to ground. This 10K resistor over here connects to that transistor. Then we have this line over here connects to that, while this line connects to this. And then the last one we have is this capacitor goes down here and is connected to this 10K. So that's it, our entire circuit is connected. Now we're already partway through a simulation, so let's just reset this over here by pressing this button. Let me just move it out of the way so we can see it separate to the circuit diagram. There we go. Alright, so simulation, let's just reset it, the time. And so it's starting to run. And if right now we're dealing with microseconds, let's just fast forward and give it a... Let's see if we can accelerate the circuit and see if something's going to happen. We're going too fast. Okay. So here we see our lights are flashing. They're flashing kind of slowly. But then again, this is like in milliseconds. So let's see if we can make our simulation slightly faster. We're going to go to other options. Let's give us a time step of 50 nanoseconds because we don't have to be as accurate as 5 nanoseconds. So there we go. We see here clearly our lights are flashing, and this is very similar to how our circuit is actually working. We've actually, obviously our circuit has the LED lights are in a circle around the perimeter of our circuit diagram. But over here we see we could rearrange these LED lights, but it'll just make the circuit slightly more annoying. So we just have them all lined up here. But we see here the lights are flashing in order, and they keep going in the same rate. So this over here is a accurate simulation of our circuit. And next video, we're going to be going into more detail to actually understand what's happening in this circuit and why is it flashing in a pattern with a simple circuit which just uses transistors, capacitors, and resistors. See you then.